There's a very nifty function on the calculator that's the store function that very few people utilize to its full potential. Now, I've done a video on this before where say if I have y equals, um, say 2x squared plus 6, and we want to find f of 2, one way of doing it is just taking 2 and storing as x. You just hit this store button and say as x, hit enter, and then you can do 2x squared plus 6. And it plugs it in. So now x is 2, and we just plug it in. It's the same thing you would get if you did it by hand. But it turns out this store function actually has a whole lot more to it. You don't have to just store it as x. Now, what do I mean by that? Well, let's take a look at an example. When I took chemistry, I remember there being something called Avogadro's number, which is like 6.023 times 10 to the 23rd. And that's a nasty number that you just have to memorize when you're taking chemistry. Well, you don't actually have to memorize. I never did. What I did was I typed into my calculator 6.023 times 10 to the 23rd, enter, and I hit store as A, which is under alpha A, alpha math, enter. So now every time on my calculator I type in A, that's Avogadro's number. So I can later on, I can do whatever, say I'm doing some other gunk here, who cares what I do. But at any point, if I need to use Avogadro's number, I just type alpha A and boom, there it is. And it stays, right? If I clear out my calculator, turn it off, turn it back on, go to the y equals, do whatever, right? I can do all sorts of stuff, and a month later, A is still A. The only way to change it is if I change it. So I just was careful not to change it throughout that class, and I used it all the time. So this is great for non-math classes as well, just for plugging it in. I love to store it as a function there. Now, there is something you do need to be very careful of. It doesn't really matter if you store it as A, perhaps, but notice that x is currently 2 right now, right? Because I stored it as 2 earlier. Now, I said earlier that A is Avogadro's number. It's never going to move. But x is very different. If you store something as x, use it quickly or don't use it. So for example, let's say I go to my y equals and I do something here. Maybe I plug in a number here, whatever. I graph it and I trace and I go along. I do some stuff. This is stuff you're likely going to do, right? Well, the graph is very well tied into x. Notice that x is 0.42. If I quit and type x, it is no longer 2. So you have to be careful if you use the x. But if you use a, it's not as big of a deal. That's just a word of caution. Now, Newton's method says that if I want to calculate a zero, say xn plus 1 equals xn minus f of xn over f prime of xn. Now, you don't really have to know this because I'm just going to state that, okay, say we have a function y equals e to the x minus 1, and we want to find its zeros. That's where this would apply. Now, xn is just some number you want to choose, it doesn't matter, minus e to the xn minus 1 is f, divided by f prime is e to the xn. If you don't know where I got that from, don't worry too much. But basically, this formula tells me, given a number for xn, what's the next one going to be as an approximation of the zero. So I'm going to take and plug in some initial value. How about 1? Store as x. That's going to be my xn. And then I'm going to type in x minus this function e to the x and then minus 1 divided by e to the x. So it's actually going to plug in 1 into that whole thing. And let's store that as my new x. So when I hit enter, I guessed that 1 is a 0, and it comes away and says, oh, 0.37 is a better approximation of the 0. But the really cool thing here, doing this store, is I just hit enter again, and it gives me a new guess of 0.06 is even better. Enter again, 0.00176 is better. And I can just get as good as I want to get, and I just keep on going. You'll notice here I'm getting like negative 2.63575 times 10 to the negative 14. That's pretty much 0. And in fact, the answer is 0. If x is 0, this whole thing is 0. So x equals 0 is the solution, which Newton's Newton's method approximated very, very well here. So to summarize, this store function is very nice for constants, like Avogadro's number. You can just plug it in and store it and just forget about it, and then you just plug it in when you want it. It's also very, very useful for values you want to remember. Kind of like Avogadro's number, but anything you want to write down, we'll just store it in the calculator instead. It works. It's also great for intermediate calculations. Basically, avoid rounding, right? You never want to round until the very end. So you can just store some number you have, do some other calculations, and then bring it back later. I use that all the time. And then the last thing, like Newton's method here, is iteration. Anything you have to do multiple times and restore it as a value and do it again, well, this works great.